Thank you. Good morning, everyone. And it's nice to be here to talk about the topic of the Compete Toolkit to ensure operational excellence by our product, Companion by Minitab. And also thank you, Jihan, for helping me to interpret the summary for you. I will use English for this section with the help from Jihan to help me to do a little bit of the translation. Okay, it's nice to know that most of you have used Minitab. Some of you have used it for a very long time. This section is going to be talk about a toolkit which actually will have Minitab and also Companion and SPM that we mentioned before. I want to know that how many of you have heard about Companion by Minitab before you come here today?
컴패니언이라고 하는 제품을 들어보신 분 있으세요?
Okay.
Just one?
Okay. So I hope you can find out more about our product, Companion by Minitab, from this section. In the data analytics space, Minitab, our statistical software, its capability actually covers from the descriptive statistic to diagnostics to the predictive statistics. Okay, so this is helping people in the statistical world to do a lot of the needs in their statistical solution. While Minitab covers some part of the predictive analytics, we also have another specialized product, which is the Salford Predictive Modeler. We call it SPM, which is a machine learning tool that's specialized in predictive modeling. I'm going to have some demonstration on that later on to let you know how this machine learning approach could do the predictive modeling that's different than Minitab. Okay, so Minitab together with SPM, this could help you to get insight in data, which could help you to make better decisions for your business. And how could you execute the decision after you use the tools to get your analyze, to find, to understand the decision that you need to take. Then you need another tool, which is the Companion, to help you to execute your decision better. Could you help me to do it about this?
예, 미니탭은 세 개의 제품을 가지고 의사결정을 지원하는 도구로 지금 사용이 되고 있고요. 여러분이 잘 아시는 미니탭은 이제 품질 도구에서 많이 사용이 되고 있고, 그리고 요새 이제 머신러닝으로 해야 되는 또 그런 문제들이 나오기 때문에 이런 머신러닝 도구를 같이 어떻게 사용할지에 대한 그런 부분을 실제로 사용을 하고 있고요. 그리고 오늘 소개를 주로 해드릴 실제로 이제 품질 프로젝트 관리를 어떻게 더 효과적으로 할 수 있을지를 컴패니언이라는 도구를 통해서 할 수가 있습니다.
Okay. Companion is a project management tool. What is so good about Companion and why it could help you to execute the decision? Companion has the common roadmaps for different type of improvement projects. For example, the common DMAIC roadmaps for process improvement projects. And also we have the CDOV for the design for Six Sigma projects. We also have the roadmap for Kaizen, for the Kaizen events, Kaizen workshops. With those roadmaps, it gives you the project direction, also keeps your project on track. And we have over hundreds of tools in Companion, which means that you could be able to find the right tool for the problem that you're facing that could help you to move your project forward rather than getting stuck with your project, the problem that you will just give you the handicap to stop you to move forward. The tools are designed to work with each other. And the data, they populate across the tools, which means if you input the data in this tool, and the data will actually be populated across the other tool that you will use. So when you use the other tool, you don't need to repeat the data entry to save your time. Okay. And because it's a centralized project management platform, so the communication will be effective and easy. It's only one place to find out all the information. This will help the communication. And today I'm going to use a case study to demonstrate how Companion and also Minitab and SPM could work together to solve a problem. The problem that I want to talk about is related to a detergent manufacturing. This company has developed a new product and launched to the production. However, for its initial launch period, the quality was not stable. One of the quality indications is the wireless. It's the ability to clean the fabric. It's called the wireless. This wireless test result shows that it had a higher fall-out rate for its initial production. So the project team want to improve this problem to solve, to find out the root cause of the problem.
예, 오늘 소개해드릴 사례는 디터전트라는 세제 제조사인 것 같아요. 그 세제 제조사가 신제품을 만드는 이제 그 활동이 있어서 그들이 생각했던 것보다 그 화이트니스라고 해서 이제 표백인 것 같아요. 예, 표백에 대한 품질이 안정적이지 못해서 그것을 오늘 소개해드린 세 개 제품을 어떻게 적용했는지 그걸 소개해드릴 겁니다.
So to start the project, I'm going to switch to Companion, which if you may have this demo file in your computer, you could open this and go through this together with me.
예, 말씀드린 대로 그 폴더에 요 파일이 있으니까 한번 오픈을 같이 해보시면 좋을 것 같습니다.
Okay. As you can see, this is the layout of a Companion software. This part here is called the management section, which contains all the forms that for management purpose. For example, the project today, which you will see the basic project information, project status and progress. With those essential information of the project. And also, there's a project charter that contains the one of the most important documents in a project. And this form just provides a well-structured form for you to fill in all this important information. Really helps you to manage your project in a easy way. And also, you will see the financial data, team members and role tasks, this type of form that to help you to manage the project. And down here, you see the roadmap. The roadmap section here. As you can see, we had, for this project, because it's related to a variation, a quality problem, that's why we want to use the DMAIC roadmap, the DMAIC Six Sigma roadmap. Okay. And you will be able to understand, how this roadmap could actually help you, to provide the direction for the project with a set of tools that actually comes with this roadmap to save your time to call out these tools. It already comes with the roadmap. But of course, you have the choice to find the additional tools from our toolbox here. Or also, you could actually modify the tools, if your company would use the tools in a slightly different ways. Okay, that's all the flexibility you could have. The first thing I want to show you in this, in the define phase is the first tool called CT tree. here. When I start the project, I want to know about what is critical to the quality, what's critical to the customer. Okay. So I have this clear information in mind to have this map out so that I know the wireless has a problem, but also want to know what others are critical to the quality and what are the relationship between these critical to quality elements in the product. I have done most of it. I want to show you that how easy it is to actually draw out this map. Here, if I want to add another one, I will just go to this icon here, infinity. Then I will be able to add one. And this new one, I will call it fabric protection. Okay, and then I will be adding a child to that. Another I could type. Okay, this is a bleach, and I put adding a sibling here, and then this one I will type abrasive. Okay, and if you find out, okay, some of them could be in the wrong place. As you work on this, you could be brainstorming with the team, brainstorming with yourself. You find, okay, I put it here, but it's in the wrong place. I can just easily move it around, it's just simple drag and drop. Will be very easy to do such command. And you could be able to also, when you brainstorm, you have come up with some idea. You can store your ideas in this side panel. I would say, for example, if I come up with something called ABC, it's stored there. And then I could actually be come back to use it. I decide, okay, this one, I want to put it here. It's just like that. If I found I make a mistake, okay, no, this is, no, I don't want to use it, but I don't want to throw it away. I'll put it back here. It just keeps there to keep the record. Okay. So this is the first tool that I use to understand the critical to quality. Then I'm going to move on to the other one that I want to demonstrate to you, which is also very important, is the process map. I want to have an idea of how this product is made and where the problem in the process is happening. So I need the process map to help me to do so. Do you think you need to? Okay, yeah. Again, I have done most of the process map, but I want to show you how to do the last two parts. It's not finished yet, so here, if I want to continue with the process map, let's go to this icon here, this arrow, and I will choose this one, the rectangle, click, and then I will type packaging. Then this is the last process, so I will go to the next one, I type N. This is just how easy you could actually map out a process. Besides those common icons for the process symbol, you could also find the other ones up here. It's not just limited to these four here, but these are the most common ones. So it makes it easy if you just use the rectangle or the diamond shape. You could also, for example, like this process here, you could also input your process input variables from here. You could add new variable, I would perhaps call it ABC. And you could also find the type of the variable, whether it's a controllable, SOP, or noise. Your data type, whether it's continuous or attributes. So you could store, by identifying your process variable, you could store them in here. And also you could also input your process output variable here. So you have a very clear information of the process, how the product is made, and what variables that's related to each process. So after I understand the process and where the problem is happening, then I'm ready to go deeper, to understand, to try to see, investigate the problem by taking measurement. I move to the measure phase. Okay. So the first thing I do is, of course, the gauge R&R, which is to evaluate the measurement system. Before I start to do any measurement, I need to make sure my measurement system is adequate. So this gauge R&R study is a statistical tool. In here, I will need to go to Minitab to help me to use the data to evaluate the measurement system. And how do I do that? I could, in this new version of Companion, I could start a project, Minitab project here within Companion. You see the way I already created a folder here. It's called Minitab project. That's where I want to put this Minitab project file there. The reason is because this project file actually will have the data for the whole world map. So I don't want to just put it in any of the world map. I want to, any of the phase. I want to put it here. So that means I can easily find this project file, and this project file contains the analysis for the whole world map. I click this, open the project file here. Yeah. I'm noting the. You may not have this data file because this has some of the information that we cannot release to you. But you can see me how to go through this statistics. Here, we will, using this data to conduct the test. I will go for the gauge R&R study. Select my this comes up with my results. As I can see, the total variation is 9.41%, which is actually quite good. It's under 10%. And from this graph here, we can see it's a better way that, let's just make the graph bigger, that most of the variation comes from the part to part, which is a good sign. Most of the system variation is due to the part to part. It's not related to the equipment or the operator. So what we can easily bring this result across to by sending it to Companion or by using copy the graph, bring it back to Companion. Now here. So to keep the important output result here for the project team to understand the result that we have done, and also to have a very clear overview of a one-page summary of what you have done for the gauge R study with all the information that we put in here. So after we understand our measurement system is a reliable system to move forward, we will then take a look at the capability of our production. This is the form for the capability. And again, we will go because it's a statistical analysis, so we go back to Minitab to conduct our capability study. we had our specification, which is 85. Okay, so from here, we can see this, our PPK value is actually relatively low, which is 0.42, well below the 1.33 standard. And also, we can see that a large portion of our sample actually falls out of this lower specification limit. So this process is not stable. This process is not stable. I could like to show you how to bring the result across here. The result, the graph the format is actually, because this companion is designed as a A4 sheet size format. So when we bring the graph over, we have to reduce the size to fit in the box here. Because in Minitab, the size is really bigger than the A4 size. This is just the reason why I have to reduce it. But it's still a simple operation to do that. And as we can observe, we can put in our observation here, which I have already done in advance. So based on this analysis, I would have to say that I have to move on to identify the factor that's affecting the process capability to understand what's the problem of the wireless test. But I also want to take a look. Now I know the process is not stable, but I want to understand further in the time series how the variation actually exists in our process across time. So I want to use control chart to help me to understand, what could be how would our production look like. As you can see, we had this out of spec variation all along our production. So we understand, okay, the problem actually keep coming back, throughout the production. It's not just in any particular period of the production. Okay. So we had two dimensions of the problem. The overall result is not good. Also, when we look at across the time, throughout the production is not good. Okay. And we could, in Minitab, we could have the analysis on the control chart. If we do the X bar chart, you could select the test here. We could perform all the tests for special cause. And then this will help us to do all the special cause tests and identify all the red dots. These are all the special cause. And with the conclusion telling us, how the failure of each test. For example, the test run, because you had 1 point more than 3 standard deviation away from the center line, and we had the other test 5 fail, test 6 fail, which point it failed. It lists out all this detail of the of the special cause to help us to have a detailed understanding of the problem. We can easily bring this observation across to our companion. Just like this, so that we had the record here to share with the team. Okay, so understand that we need to identify the factor, to tackle the factor that affecting the wireless, to tackle the wireless. Okay.
예, 제가 지금까지 좀 진행된 거 간단하게 좀 요약 정리해 드리면요. 일단 이제 아까 전에 디터전트 신제품 문제가 일단 발생이 됐잖아요. 그래서 프로젝트를 이제 컴패니언으로 시작한 겁니다. 그래서 우리는 어떤 로드맵을 가져갈지를 여기서 정했습니다. 예, 여기서는 이제 디맥 로드맵으로 정했고, 그리고 이제 첫 번째 디파인 쪽에서 아까 전에 크리티컬 투 퀄러티라고 하는 브레인스토밍 툴을 쓴 거고요. 사실은 뭐 피시본 차트하고 쓰는 거하고 거의 같고요. 그리고 프로세스 맵도 그리고 현재 품질 수준이 어떤지를 미니탭에서 분석한 거를 그 다음 매저 쪽에서 아까 전에 이제 거기다 갖다 정보를 붙여 놓은 거예요. 거기서 분석을 한 거는 미니탭에서 분석을 한 거고, 그렇게 해서 이제 저기다 정보를 넣은 거. 전체적으로 보시면 컴패니언이라는 도구를 가지고 예전에 뭐 PPT나 엑셀로 이렇게 쭉 관리했다고 하는 거를 이 도구를 통해서 전체 관리를 하고 그 안에서 필요한 여러 템플릿들을 쉽게 사용을 하는 도구로 일단 사용을 하고 있고요. 그리고 지금 보신 게 이제 영문 일단은 버전이긴 하지만 템플릿은 사실은 한글 버전으로도 만들 수 있어요. 예, 사용자가 변경 가능하기 때문에 뭐 회사에서 주로 이제 쓰는 어떤 로드맵이 있으면 로드맵도 사전에 정의를 사전에 해놓을 수도 있고, 템플릿도 우리가 주로 쓰는 폼이 있으면 그걸 변경해서 그 템플릿을 디폴트를 정해놓고서 또 쓸 수도 있고, 그래서 그거는 뭐 유연하게 일단은 사용할 수 있고요. 조금 더 하나 더 설명드리면, 지금 현재는 하나의 프로젝트를 수행을 하는 겁니다. 여기서. 근데 이제 전체 회사에서는 프로젝트 하나만 수행이 되는 건 아니잖아요. 그렇게 되면은 현재 우리 프로젝트가 전체가 어떻게 되고 있는지, 그리고 실제 성과는 어떻게 되고 있는지를 실제로 대시보드하고 연결을 시킵니다. 인터넷 포탈 쪽으로. 그렇게 되면은 예전에 어떻게 보면 식시마 포탈 예전에 쓰신 분들 아실 거예요. 예, 거기는 뭐 여러 가지가 있지만 이거는 이제 품질 프로젝트를 관리할 수 있는 포탈까지를 이제 연결해서 그렇게 이제 전체적으로 사용을 하고 있다 보시면 될 것 같아요.
Thank you. Yeah. So I want to go further to find out the factor that's affecting the wireless. Okay. To do so, I will have to use a tool called C&E Matrix in Companion. This is a quantitative analytic tool. In here, what I want to do is I want to find out, okay, what would be affecting the wireless. I have done the process mapping before, so I will have already identified a list of our process variables. I want to see, to establish a relationship and to understand the importance of this input variable to some of the important output variable like roughness, solubility, odor, etc. So in here, I don't actually need to type the because I say data they actually populate across the two. In here, I will only have to use the pull down menu to select the process. For example, I will have to select this one. Is one of the processes called acting heat sensitive ingredient. So in the variable is bleach. I will have to then put down the rating for this bleach in relationship of whiteness, solubility, or odor. And second one is the surfactant concentration. Also, I will put down the rating again. As I compute it, I will have some of the key information automatically calculated for me. For example, all these percentage and the Pareto chart down here. I would to show you how easy it would be to come up with this chart. If I change this from 7 to say 10, it will be like this. But going back to 7, or I change this to 10, it works out very fast. As you type in the data, this chart will just be done immediately. So results are actually generated very, very fast. You could as soon as you finish typing all the data, you will have all these results in front of you. And from here, this analyze, we understand that the surfactant concentration is actually a very important key factor to the wireless. This is based on our process knowledge or product knowledge. We know that, okay, we have come up with level down to this input called surfactant concentration. But this is not enough. We want to be able to understand more about how this surfactant concentration and the wireless are related to each other by using data. But this helps us to actually understand, we need to look in this direction. Then the next step is to use data to find out more about this relationship. So I have to use regression analysis. In Minitab. And I want to show you, if some of you have not know or not used the assistant very often, I want to show you actually this is also a good tool. It's not just for people for the beginner level, but some of the assistant concept is actually to help you to do things faster. Okay, why? Let me show you. For the regression test, okay, I want to use the assistant. I go to regression. Okay, I follow this flow chart here because it's one X variable, then it's a simple regression. Okay, our Y is wireless, our X is surfactant concentration. Normally, if you use the regression in the stat menu, you will have to first assume whether the model is a linear or quadratic, right? But for the assistant, why I say it helps you to do things faster or easier, is you could select this choose for me. I just do that and to show you what could happen. Okay, it comes up with a model. Actually, it's a quadratic model. You can see that there's x squared terms here. But when you look at it's actually quite close, very, very close to a linear model. So that means sometimes if I use the regression in the stat menu, I start with assuming it's a linear model. And I will use a indicator, which is the R square, to see how my model fit to my assumption. If I use linear model and the R square result is 87.8, which is not bad, it's still quite high. I could just think, okay, it's linear. And if I assume it's linear, it could have some, it's not, if it's a straight line, it could have some error in the prediction. Actually, because it's slightly curved, right? Slightly curved. And you see, the quadratic is 86, so it's slightly higher. That means the quadratic model fits better to this relationship. If you have to do it by yourself, you have to do twice. Once linear, once quadratic, and then you compare manually. But the assistant do this all for you behind the computer. So sometimes it's a good thing to make use of this computer power. It's not just for the beginner. It has some feature there that helps you to speed up make your work faster, which I like it. And from here, I would want to find out more about our target of the surfactant concentration. By adding a reference line to find out if I want my virus to be at this 85 or higher, what could be my surfactant? Is you can see here the upper left corner, 0.387 is the value. Okay, so I could just do this again, add another reference, which this time I do it for the X, 387. Okay, by doing that, I understand if I want my whiteness to be higher than 85, my surfactant concentration needs to be more than this value. So what we want to do, what we found out from this regression analysis is this is the region that we want our surfactant concentration to be, to help us to improve the quality. Then I can bring this graph to companion, just like what I have already done. Okay.
지금은 애널라이즈 단계 세부 내용은 말씀 안 드릴게요. 아시겠지만 일단은 분석 활동을 한 겁니다. 그래서 CNE 매트릭스 혹은 FMEA 아시는 것처럼 Y에 영향을 미치는 X, 치명 X가 뭔지를 찾았잖아요. 근데 거기서 아까 전에 폼에서 보여준 거는 그 정보 하나하나를 새로 다 키인한 건 아니고요. 아까 전에 프로세스 맵이라던가 그 전에 피시본에서 만들어놨던 정보를 그대로 다 가지고 오는 겁니다. 예. 그래서 어쨌거나 거기서 점수를 매겨서 중요 X인자가 뭔지를 찾았고 회귀 분석까지를 이렇게 들어갔다고 보시면 될 것 같아요. 지금 여기서의 핵심은 미니탭 분석 이 세부 내용이 중요한 게 아니고요. 실제 프로젝트를 어떻게 끌고 오는지에 대한 이런 절차를 한번 좀 더 이렇게 이해하시면 될 것 같아요. 그리고 혹시나 중간에 좀 궁금하신 질문 있으시면 저기 아까 안내해드린 슬라이도 sli.do 쪽에 질문을 좀 남겨주시면 마지막에 질문 선정해서 또 선물도 드릴 예정에 있습니다.
Okay. So I know how to focus. I will focus on improving the surfactant concentration. So how do I do that? I need to use a fishbone diagram to help me to understand, to help me to think, to brainstorm how to improve surfactant concentration. Surfactant concentration is a chemical compound that quite commonly used in a detergent. Okay, as you can see, I have already listed down some of the factors here. I cheat a little bit because this is just how to remember what to put in here. Say in case in the real world, if I work in a fishbone diagram, I list out all my idea here, and then I want to bring it, to fit it back to the fishbone diagram. I could just do it like this. This flow rate is related to the process setting. Mixing speed is also related to process setting. That's how easy it is to be done. Drag and drop, and the layout will automatically adjust, to make it symmetrical. Fishbone diagram is quite similar to the CT tree, the logic, but it just the layout is slightly different. It's a good brainstorming tool that you could use to do everything in the software. No need to do it on paper. You can brainstorm your idea here, and you could just drag and drop and play around with the whole fishbone diagram in the software. So from this analysis, I understand, okay, these are the factors that could affect the surfactant concentration. Okay, so I need to collect some data to understand where the problem is and how could I make our surfactant concentration to be greater than that 0.385. Okay, in here, I need to turn to, because you see, we had a lot of factor here to collect the data. We could collect the data from the production line through the sensors and machines. We collect the data in a automatic, by automation manner. A large amount of data has been collected, okay, but because the production is at that point is not stable, so there are quite a lot of outliers in the data, and also some because the data is collected automatically, so it's no human monitoring throughout the process. We don't even know if sometimes we have some missing data that's not able to collect from the production line. So we're facing a data set with many variables, with outliers, with missing data. And it's this reason that we want to use machine learning, SPM, to help us to do the analysis. Because machine learning, it looks it looks at the finds pattern from data to make the prediction model. So it takes another approach that we don't have to worry about the outlier could actually affect our accuracy. So I want to introduce to you a little bit of SPM. I have collected the data already. I would open the data file to show you. This is what our data looks like. Okay, we had these equipment tanks that we come, that's from our fishbone diagram. We collect all this data, and also we have our target surfactant concentration in our data. So we go back to model our data. We had close to 2,000 records of production data, and a total of 11 variables. Okay, we go to this model menu. In the target here, we want to find, our target is surfactant concentration. The predictors, which are the variables that we just identify. In this case, it's all of the variables here except for this one, because this one is our target. I just want to take this one because the tank, even though it's number, but actually it's a categorical variable, because tank 1, tank 2, they just had no numeric relationship with each other. And this is the regression test. So let's see what we get. This is what we call a card tree, a card tree algorithm in machine learning, because it will show the result in a tree structure that we could easily understand, how to get to the result here. I would like to show you that if we're going to look in this color coding tells us red is the high value area. If we go here, you will see the mean value is 0.5. That's our surfactant concentration. That means the high surfactant concentration we can get is 0.5, the mean value. Okay, and how do we get this value? We can look further, look into some of the statistics, but we are interested in knowing the rules. Oh, it tells us, okay, equipment and mixing speed could help us to get to that high surfactant concentration. Okay. We can look into each of the nodes here, or we can look at the whole tree like this. So we can see, we were looking at this one before. 0.503. If we look at the whole tree, we understand a lot more. How could we get high surfactant concentration like this one or this one? We will have to, the variable that we have to concern about is the mixing speed and the equipment. For this one, the highest surfactant concentration, we need a mixing speed of 13.95 or greater. We need to have this equipment called CL to get us the best result, the highest result. But we know that actually we cannot just use one equipment for the production. We have many other equipment here that what do we do with it? And luckily, this analysis also tells us for this equipment, with a higher mixing speed, we could still get not as high as 0.5, but 0.421, the second highest surfactant concentration. That means we have some idea of like how to get high surfactant concentration. We have to adjust the mixing speed. We have to use the certain equipment. But we know that we cannot just use one equipment. We have to use, what if I want to use all the other equipments? What can I do? There is a way we can do it. It's by setting a higher speed. Okay. You mean a companion?
지금 이제 회귀 분석까지 했잖아요. 근데 갑자기 머신러닝으로 왔어요. 왜 왔냐면은 기존의 전통적인 통계 분석으로 할 수 없는 그런 데이터류가 있습니다. 예를 들면은 미싱 밸류가 많다던가, 혹은 아웃라이어가 있다던가, 혹은 회귀 모형으로 설명이 안 된다던가, 그런 문제들은 기존의 회귀 모형으로 그대로 사용할 수가 없거든요. 이제 그런 경우나 또 다른 어떤 이유의 경우에 머신러닝을 이제 그때는 적용을 하는 거고요. 그래서 아시는 것처럼 머신러닝은 학습을 통한 예측이기 때문에 아까 전에 이제 카트라고 하는 모형을 쓴 겁니다. 그거는 가장 중요한 변수부터 쪼개서 계속 가지를 만들어요. 그렇게 되면 최종의 단계에서는 예를 들면 Y가 어떤 조건이 되기 위한 각각의 시나리오들이 다 나오는 겁니다. 그래서 이제 아까 전에 머신을 굳이 이거를 쓰지 않고 이거를 써도 되는 조건을 찾게 되는 거예요. 그래서 회귀 모형하고는 기본적으로 접근법이 다르기 때문에 지금은 이 문제에서는 머신러닝을 통한 좀 더 옵티멀한 조건을 찾기 위해서 머신러닝을 여기서 적용했다는 얘기를 한 거고, 지금은 이제 컴패니언의 A 단계 마지막으로 머신러닝까지를 적용한 거를 설명한 겁니다.
Thank you. Okay, sure. Also, I could just bring back the result that I have done in SPM back to Companion. This is a form that I actually I designed by myself because it's not a standard form in Companion. But the good thing about Companion is you could design your own form, or I just modify this form from the standard regression analysis because some part of it are very similar. It's just the analyze part is different. So I modify this part here so that I could fit in the result that I generate from the SPM, bring it back here. Okay, so from the analysis in SPM, we know that we should go for the mixing speed, we should go for the equipment. But I want to test out what is the process capability of the result that recommended by the prediction model in SPM. It's telling me that if I want to go for using all this equipment, if I have an average of 0.421 for our surfactant concentration. Okay, so I want to know what is the capability of this mean value here. Then I will use a powerful tool in Companion called Monte Carlo simulation. Remember, we got our regression equation earlier, which is the y-ness actually is governed by this equation here. It's a quadratic equation, remember? Okay, so we can import this solution from the regression model to here, and then we would have to input the mean value that we generate in the in SPM and the standard deviation that generated by SPM. We just want to see what could be the simulation result to tell us what could be our capability. And maybe I just want to show you how fast it could have generated the result. I simulate 500,000, 50,000 times. You could use 100,000 times or even more. But this is actually should be enough. As you can see, actually, the capability is not satisfactory. We just because as expected, because we had done nothing to improve our process up to this point. We have not improved anything yet. We just found out the root cause is the surfactant concentration. We found out how to make what are the variables that we could make our surfactant concentration higher, right? We haven't done any improvement yet. So that's the result similar to the first capability analysis we had done. So how can I want to set a target for my improvement to get more direction for my improvement? I can use Monte Carlo to do that. I can go to parameter optimization here. Okay. I know my current mean is this one, and I want to, so I know that I need to set my mean to be higher in this direction to get to improve my capability. So I try this value and see what happens. Actually, you need to try a few times. Sometimes you don't get it straight away, but because I've already done it, so I know that value will work for me. See, after that I get a 1.39, which is above 1.33. So I know, okay, they give me the exact target, a very spot on target that we should go for to get our CPK value. This is the target. We should target our mean to be 0.518, and assuming we keep our standard deviation as 0.042. So that means we know that what equipment to use. We know that we have to adjust our mixing speed to get to this mean value. Then we could solve our problem. A spot on, exactly we could, once I get that, I will be also assuring my CPK will be satisfactory. So this, the whole project shows you how we use a set of tools to help us from understand the problem to go further to find out the solution. With simulation, we can assure how to get the exact range of our target. Once we move on to this direction to get the improvement done, then we could get the result in a satisfactory fashion. To save our time, effort, we don't have to, make many mistakes in a project or do many trial and error. We could use the tool to help us to get things done in an efficient and effective manner.
예, 임프루브 단계에서 아까 이제 머신러닝에서 모형을 찾았잖아요. 예. 그거 모형을 한번 검증을 한 거예요. 실제로 바로 필드 적용하지 않고 그걸 검증하는 방법으로 몬테칼로 시뮬레이션이라는 기법을 썼습니다. 그래서 아까 전에 그 불확실성에 대한 확률 분포를 정의했고요. 그 모형에다가 적용했을 경우 우리 품질이 얼마 정도가 나올지를 시뮬레이션을 했고 보니까 품질이 좀 안 좋았어요. 그 조건 그대로 했을 때는. 그러면은 조건을 어떻게 변경시켜야 될지에 대한 최적 조건을 또 찾아야 되거든요. 그래서 옵티마이제이션을 아까 했습니다. 조건을 이 타겟 밸류를 예를 들면 표준 편차는 좀 건드릴 수가 없으니까 타겟을 어느 정도 조정을 하면은 품질이 어떻게 될까를 그것도 사실은 시뮬레이션 한 겁니다. 예. 했더니 품질이 좋아진 거를 확인했어요. 그러면 이제 그 이유는 실제로 다시 한번 실제 필드 테스트를 한번 또 해봐야겠죠. 실제로 또 그렇게 될지를. 그래서 이제 1년의 과정을 이런 프로젝트를 어떻게 끌어오는지를 이런 도구 관리 툴하고 실제로 또 분석 툴하고를 같이 병행해서 이렇게 실제로 쓰고 있는 그런 사례를 소개해 드렸다고 생각하시면 될 것 같아요.
Okay, okay. So I hope by this case study, the demonstration, you understand how our Minitab product suite could work together as a complete tool set to solve problems.